At the end of last year, we did a lot of expansion of brackets, and we were working on our algebra skills, and we saw that we had to expand brackets, and we did that sort of thing. Now, what we want to do is reverse that. This time we want to have expressions we want to reverse and put brackets in. So there's going to be lots of skills and topics where this is going to be required as something we need to do regularly. Now, you've done factorisation before, what we call factorisation. You know factorisation is putting brackets in. So having an expression or an equation and then factorising by putting brackets in and getting products. And that's what a factor is. It's a product of something. So we're going to look at the different techniques and get hard, look at things where it gets harder. The first one, though, you've done similar things to this before. Now, we'll look at some harder problems, but some things like the first few here, you've seen this before, like 4x squared plus 8x. So when you look at something like that, well, you know that that's going to have a common factor to factorise. So we look at what's the highest common factor. Now remember, the highest common factor is what's the highest number and pronumeral that goes into that one and into that one. Well, 4 obviously goes into 4, 4 goes into 8, so 4 would be the highest common factor there. X goes into x squared and x goes into x, so and that's going to be the highest common factor for the pronumeral. So 4x goes into both of those. Now, is that the highest common factor? Well, we should know once we expand, when we look at what we get in our brackets, and then be able to expand out and say, well, does it get back to that firstly? And if it does, is there anything else that's common in our two terms that we've got? So we got the 4x out, so we look at, well, 4x times what would give us x squared? And that's where we get that this term must be x, because 4x times x gives us 4x squared. Then 4x times what gives us 8x, and that must be 2, because 4x times 2 gives us 8x. Is this the lowest way in which we can express this function, or this expression? And it is. We cannot find any common factors there. It's got an x and a 2. There's nothing that's common that we could keep going at. So 4x was our highest common factor. And that's what we've got to try and do. We can factorise and get a common factor out. But we always want the highest common factor. We don't want to have any common terms left in our brackets there, because we want to get them down to its most simplified form. If we look at something like b, again, the 5 goes into 10 and 15, so the 5 would be a common factor. And we've got an x squared, xy, x squared y. Well, x goes into each of those with no remainders. So it means that we factorise 5x out. 5x times x would give us 5x squared. 5x times 2y gives us 10xy, because 5 times 2 is 10. X times y is xy. And 5 3s are 15. And we've got x times x gives x squared. And we have the y there as well. So that's how we get that expression there. We're looking at, well, once we have 5x there, what needs to be multiplied back in the bracket to give us that term? So again, looking at some other examples here, 10ab minus 6a squared. Well, the highest common number that goes into both of those evenly is 2. Leaves us with a 5 and a 3. And we've got ab and an a squared, so a can come out and leaves us a b with an a there. So a times b gives us ab, a times a squared. So we've got to be really careful with these. And again, like most things we do, these ones are pretty simple, but we've got to follow and be careful of common errors. 12, 8 and 20, the highest common number that goes into all those is 4. So 4, then we get the 3 there, because 4 3s are 12, 4 2s are 8, and 4 5s are 20. And we've got x, xy, x squared y, so x can come out, and we get those pronumerals in. Again, what does x multiply by? To give us those terms. Again, be careful with the signs as well. So it's always important to be careful with our signs. Factorising these ones. Now, this one's a little bit harder. And we'll say this more as we go through the course this year and into our senior courses. What we try to do a lot of time is to simplify things, is not necessarily expand brackets, but to factorise. Factorise is always the way to go. You'll find this a lot when we get extension 1 stuff, and we'll say this a lot more, and hopefully you'll get to think this way. It's not always a way that's natural to think sometimes. but it's the way I really want you to go, is to factorize before you expand. If you can factorize something, it starts to make it much easier to manipulate and deal with. So for example, in this one, you're looking at what's common here. It should be pretty obvious that g minus 4 is a common factor, because 4g is multiplying by that, 3 is multiplying by that. So we can take that out and get our g minus 4 as a common factor there. And again, what multiplies by g minus 4 to give us 4g times g minus 4? Well, that's where the 4g's in a bracket there. And we've got the minus 3, so that's where that minus 3 comes from there. And that's in its most simplified form. That's a nice way to do it, because we've got two factors there basically multiplying each other, two brackets with, and then multiplying, which that's how we really want to end up with a lot of things being written. For this one here, g plus 1 there is a common factor, because we're doing multiplication. So we can factorize g plus 1 outside, and we've got 2g plus 3 plus g minus 3. So when we do that, g plus 1 stays there. We get 2g plus g, because we can simplify this bracket now. And 3 minus 3, well, that will cancel each other out, which leaves us 3g, which starts to make that look a lot simpler. That's what that would come down. That's what that comes down to. But we've achieved it without expanding this and then collecting like terms and then factorizing. This is a much more efficient way of doing that. So that one's not easy, but it shows the power of factorizing rather than expansion and factorizing. Okay, so the next type of factor is one we wanted to concentrate on. It's called difference of two squares. Now, we've heard this before. Now, if you remember from last year, we were looking at the situation where we've got a bracket where it's got a plus b and another bracket where it's got a minus b. And we saw that that was a squared minus b squared. Now, we did a number of those last year in the last couple of weeks of term, and we really stressed that result, as well as some of the perfect squares and things like that. So we're making life easier to go from that point to that point by knowing this rule without having to expand or do that. What we want to do now is be able to go backwards, is say, well, if we've got a squared minus b squared, let's be able to factorize and put it straight back into that form. So the difference of two squares can come back to this. And that's what we're looking at with this one. We're just reversing that rule, recognizing that we've got an x squared and a 25. Well, it's two squared terms, and with a subtraction sign there, that's a difference of two squares. We can write that. So that's really easy to do if we recognize it. And that's what we've got to get used to, is being able to recognize that we've got that situation and just going straight back to those brackets there as we had in the rule. 4y squared minus 49x squared comes down to 2y minus 7, 2y plus 7. So again, square root of 4y squared is 2y, square root of 49x squared is 7x, so it comes down to the 2. Remember, two brackets there, same terms, but they're conjugates. Hopefully remember that term, conjugates. And we're able to write it there, and it's factorized. It's in a nice form, ready for us to do some other work with it. Factorize these expressions. Well, always look for the common factor first. Now that's what we've got to get. That's something we've got to get used to as well. When we try to factorize, can we get a common factor? That's the easiest thing to do. Can we do that? We often forget it. But if we look at this one, 45x squared minus 20 has a common factor of 5. So the 5 can come out straight away. And then we've got 9x squared minus 4 in our bracket, which, when we look at that, is the difference of two squares. That makes life easy. So we're able to go, okay, let's take the difference of the two squares. 9x squared, factor square root of that is 3x. Square root of 4 is 2. So we get a nice two factors there, and it's in a nice factorized form. Again, we can do more with it later on. Again, this is a tricky one, and sometimes it's not recognized as a difference of two squared, but you've got something squared minus something squared. We can factorize it this way. Take the square root of x plus 5 minus the square root of x minus 4, all squared. So we get those two, and then we do the same thing, we add them. But these can be simplified. These ones up here couldn't be simplified, but here we can. So we get x minus x, that goes. 5 minus 4 gives us 9. So that simplifies down to 9 in a bracket there. And x plus 5 plus x minus 4, well, it gives us 2x. 5 minus 4 is positive 1, so we get the 2x plus 1 in the other bracket. Now we could expand that out, collect our terms, do our subtraction, and then factorise, and obviously we'd factorise a 9 out, and we'd get down to the same thing. Here we did it in 2 lines. Doing it that way might take 4 or 5. See the power of being able to factorise before expanding, and that's what we're trying to get across. If we can factorise in the courses now as we go along, that's going to be more powerful for us to solve some of the problems we're going to have to face.